Okay, so now it is asking for the moles of CO2 generated in the reaction. Okay, so we have the mass, we just convert that to moles. That is a simple problem. Okay, um, and yeah, so we have the molar mass of carbon is 12.011, of oxygen 15.9994. I have two of those, so there's carbon plus 2 times the oxygen. Here's my molar mass, grams per mole for CO2. Okay, carbon and oxygen, and up here was just grams. Alright, so here's my molar mass. I'm going to take the mass and divide that by my molar mass to get the moles. Okay, and I will do the same thing with my other trial where I had that was for this trial. Here I have 1.3662. So if I do that, then I'll have this mass and that many moles. Okay? So here is my moles of CO2. 0.03104. Okay? And the other one, 0.02980. Alright, now we calculate the value of R. Okay, we have gone through, we've found pressure, we've determined the volume, we just did the moles and we did the temperature earlier. So the value for R is going to be the pressure times the volume divided by N divided by T. Okay, so going back over here, we'll have R equals PV over NT, right? And that's going to be my pressure of the carbon dioxide was in the atmospheres there, times the volume of the carbon dioxide here. Of course, I had it in milliliters, so I need to put that in liters by dividing by 1,000. Then I'm going to divide by the moles. Okay, so that's going to be that one, and divide that also by the temperature. And I am using the second trial data here. So let me make sure I get the temperature for the second trial, which was 295.45. Okay. And there we go. There's my value in liter atmospheres per mole Kelvin. 0.04806. Now that's for my second trial. So I'm going to update my numbers here. For the pressure, 0.9809 was for trial 1, and my volume for trial 1 was, where is it? Okay, here we go. 0.426, okay, liters. Okay, so now I can take that pressure times the volume, and that's in liters, that's in atmospheres, per per mole, and this time for trial 1, divided by the temperature for trial 1, which was 294.35. Okay, so here is for trial 1, this was for trial 2. So 0.04580, and for the second trial, 0.04806. Alright, so that's calculating R. Now we're going to use, we're going to calculate the value of R again, but this time we're going to use van der Waals equation. Okay, in the lab guide it talked about van der Waals equation. It's a variant of the ideal gas law, except a little bit more detailed. Okay, but you see there's the pressure, the volume equals nRT. So we just have this correction to the volume and a correction to the pressure, because the ideal gas law is for ideal gases, and this is for real gases. Okay, the ideal gas law works under certain conditions, but when you start to get under higher pressures and more interactions between the atoms or molecules, then the van der Waals equation kicks in, or it works, it gives us a little better results. Okay, and so we're going to, let's see, where was I? Over here. In the lab guide also, it gives us the values to use. Here it is, for A and B. They're constants for the given gas, and these are the values that I'm going to use. A is 3.592. Okay, so I'm going to put that here. And the units are liters squared, atmospheres per moles squared. Okay, so it looks something kind of like that. And let me put in the value for B as well, 42.67 cubic centimeters per mole. So again, these are constants for a given gas that we plug in here for A and B into our gas law. Okay, and N, of course, is the same N, the moles. All right.